Okay, exponents is our topic for today. So an exponent, if you guys remember, PEMDAS stands for parentheses. Say it with me.
Parentheses.
What's next?
Exponent.
Exponents.
Multiplication.
Division.
Addition. Subtraction.
Division. You guys even got a little ahead of me. Addition. And subtraction.
Oh wow.
So these four, you guys probably did a lot in elementary school. Multiplication, division, addition, subtraction. But exponents is new for a lot of people in middle school. You might have seen them before. You might have heard of them. You might know what they are. But we're going to learn a lot of new things about exponents this year. So I want to just make sure that everyone knows exactly what an exponent does. Okay? So parentheses, remember we talked about parentheses could be like this. It could be like this. Sometimes you'll see curly brackets. Just like any of those symbols, those set aside, do this first. What do exponents look like?
An exponent, so let's say you had 4, and then you would have a tiny number in the top right corner.
A tiny number in the top right corner, right? So maybe
So if it was 3, that would be 4 cubed.
exactly. So that is our exponent, right? Multiplication. What are the symbols we could use for multiplication?
We can use a circle.
So we can use a time symbol or an X.
You can use parentheses.
The dot.
You can use a dot. You can use parentheses, like two numbers next to each other. Proximity means
and then you
multiply.
can also just have 2 numbers like.
Yeah, so I could have just one of those numbers in parentheses. This also means multiply. That means 2 times 3. Right, so all of these are the same thing. I don't know, I wrote one of them the opposite way, but 2 times 3. Sometimes you'll see this symbol too.
What?
It's like a little star. On a lot of calculators, especially on your phone, the star symbol is sometimes used for multiplication.
It looks like somebody did like an addition symbol in like pen and then
Like did a
over it.
Yeah, that's what I do.
So any of those things. What's division look like?
Just the weird whoop, dot.
Okay, the
it's
what?
like a
The
subtraction sign with 2
the
dots.
whoop dot dot. There are some other ways.
But there's like the
We've
upside
got
down
long
L.
division, right? Like 300 divided by 2. There's also, I know Gary told you guys this, every fraction is actually a division problem. So this means, actually, I'm not going to use 2 divided by 3 because there's no way to simplify it. But if I had 9 divided by 3, this fraction is the same thing as the number 3.
3 over 1.
Yeah, or even just the number 3. Because this means 9 divided by 3. You could even have a bunch of things in the past. You could have something like 2 plus 1 times 5 over 14. And this little symbol still means divide in the end. So you have to figure out what the top is and what the bottom is, and then the symbol is telling you to divide. Sometimes you'll see the same thing, but you'll see it written this way. That looks like a date, right? Like 9/3 would be September 3rd. But you will sometimes see this used as a division symbol as well. There's a lot of things that division can look like.
They use that in a lot of cooking.
Sure.
Oh yeah, they do.
Yeah. How about addition?
Just the plus sign.
Pretty much just the plus sign and subtraction.
A line.
A line.
Yeah, the minus sign. Okay. So we're going to focus in on exponents. Because I think you guys have seen a lot of this before. We will come back to fractions and how every fraction is a division problem. Because every fraction is a division. Yeah. Let's go that way. So lots of different options for the way we write this. So what are exponents?
It's basically it's times by itself, but instead of just writing it all out, they just put a little number above it.
Nice.
Yeah.
Now I'm going to write it in a very algebraic way. I'm going to say x. An x could be any number.
Let's say it's 3.
Any number. We'll give an example in a second. And then we'll say to the n power.
What?
And n could also be any number. That's the number system. So x to the n, x could be any number, n could be any number. Pretty much. For now we're going to say, let's say they're positive numbers. Or I'm only going to give you positive. This means x times x times x times x dot 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 dot. So dot 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 means just keep going. How many times do we do this? We do it n times.
So it's like.
So what does that really mean? Well, if I had a problem like this, 5 to the 3rd power.
Then it's 3 5s.
What's my x?
Oh, 5.
Now, 5. And I'm going to multiply it times itself.
Yeah.
How many times?
5 times.
No, 3 times.
3 times. Yeah. You said it.
Oh.
Oh. So do you see how 5 to the 3rd power is 5 times itself 1, 2, 3 times. So 5 times 5 times 5 is a pretty big number.
25
Yeah.
times 5.
It's like 125.
It is actually equal to 125. Nice work. 5 times 5 times 5. Now you could do this on a calculator. Okay? With exponents, you could just type in 5 times 5 times 5. That would be totally fine. You could do it off to the side. You could say, well, I know 5 times 5, that's 25. And then maybe off to the side, I'm going to multiply 25 times 5. What did I just do? There's no second. I was going to just do it again. Okay, 125, right? See, I told you I make mistakes all the time.
What did I just do?
All right, let's do another example. So that was our first example. Here's our second one. What if I had 3 to the 4th power? Let's just say, what would that equal, like, if we were to write it out, not the number yet?
4 3s.
4 times.
Nice. So 3 times 3, and I'm going to have 1, 2, 3, 4 of them.
Okay, so 3 times 3 is 9, then 9 times 3 is 27, and 27 times 3.
Or here's another way to do it.
Oh.
3 times 3 is 9.
Okay.
3 times 3 is 9. What's 9 times 5?
81!
81.
Yeah, okay, that's actually an easier way to do it.
Yeah, and so sometimes we'll look for those patterns of grouping, right? Because sometimes in multiplying it can be helpful to group. And remember, PEMDAS technically says to go left to right, but if we're just multiplying, we can multiply in any order that we want. That's okay. There's a name for that. Do you guys know the name for the rule that says, like, I can multiply these two together and these two together?
No.
It's called the associative property. It's like I can associate these two and I can associate these two.
I know.
So, alright. Let's just do a couple more examples. Erase that. So just remembering our definition of an exponent. Let's talk about this. What if I had 2 to the 5th power?
2 by 5 2s.
2 times
5
2.
2s. 2 times 2.
25.
1, 2, 3, 4, 5.
So that's 4, 8,
So we could say
16,
4.
4, 8.
2 times 4 is 8. 8 times 2 is 16. 16 times 2 is...
2.
So 2 to the 5th power is 32. What if I had 7 squared?
7 times
7
7.
times
14.
No, that's
49.
7. Right, 7 plus 7 would be 14. But in this case, we're multiplying, and 7 times 7 is
49.
ready. I'm going to leave that up. I think that's good. Do you guys have any questions before I stop the recording?
I think I'm good. Yeah, I'm good.